Your Agentforce pilot is successful. Great CSAT, no outages, everyone celebrates.
Then Monday hits. Nothing breaks technically, but finance calls. Why did Salesforce AI burn through the budget over the weekend?
That's the new failure mode. The system is healthy and still bleeding money.
So here's the uncomfortable question. Who has the authority to pull the kill switch before the invoice becomes the incident report?
Welcome to the deep dive. And that opening scenario, it isn't just a hypothetical. It is really the inevitable outcome of what we're calling the consumption gap in enterprise AI.
Right.
We've been digging through all the source material on Agentforce's new economic model, and our mission today is, well, it's to give you the blueprint for financial survival.
That's it.
We have to dissect that gap, understand these new cost physics that are driving this uncapped spending, and most importantly, define the governance. The kill switch architecture you need to contain this is just unprecedented financial risk.
Look, for any organization moving into this, understanding that the financial liability has shifted, that is step one. It's everything.
It's a whole new world.
It is. Just think back, the last decade of enterprise cloud. SaaS 1.0. Our financial planning was, well, simple.
Predictable.
Incredibly predictable. The costs were fundamentally fixed. We were in a capital expenditure mindset, a CapEx mindset. You bought a seat license? It was just headcount multiplied by the license tier. Simple math.
That system was gold for finance. I mean, absolute gold. Variance was basically zero. The only real financial risk you carried was shelfware, paying for a license someone didn't use.
Exactly. It was a static cost.
Yeah.
You could model it out 3 years ahead. The CFOs loved it. It gave them comfort.
But with Agentforce, that entire model is it's flipped completely inside out. We are now fully, 100% in an operational expenditure mindset, an OpEx world.
And that means the cost is variable, it is mathematically uncapped,
Yeah.
and it's tied directly, minute by minute, to the system's, let's call it cognitive load.
Cognitive load. And that calculation is so much more complex. You're paying for conversation volume, sure, but also agent actions through flex credits and then these hidden internal Einstein requests that are tied to how hard the system is thinking.
Yes.
We have completely decoupled software cost from human headcount, and we have coupled it directly to the system's thinking effort.
And that right there creates this profound risk delta that finance is just not prepared for. Think about it. An optimized human employee who handles, say, 3 cases an hour costs the exact same in licenses as an inefficient human who only handles 1.
Right. The cost is the seat.
But an inefficient autonomous agent, one that needs multiple internal reasoning steps, or he gets stuck in some kind of circular logic or retrieves way too much data, that agent costs significantly more than an optimized one.
The moment you deploy that agent,
The moment you deploy, you transfer the financial consequence of its inefficiency from Salesforce directly onto your own P&L.
it's the ultimate liability shift, isn't it? The vendor, they indemnify the IP of the core model, but the customer, you bear the financial consequence of that agent's autonomous and potentially wildly inefficient decisions.
It's baked into the architecture, the Atlas reasoning engine. It forces you to pay for the process of reaching a conclusion, not the quality of it.
Which brings us to what has to be the killer line. This should be the headline for every single executive meeting on Agentforce.
Say it.
You don't pay for outcomes. You pay for the attempt.
You pay for the attempt. A hallucinating agent, or one that's just spinning its wheels on an impossible problem. It doesn't just fail to deliver value. It is actively burning through your budget in real time, faster than any human could possibly track the receipts.
Okay, let's get surgical on these cost physics. We really need to explain the fundamental architectural shift that's driving this consumption problem. Old systems, they were deterministic, rigid logic flow.
Right, and if the condition wasn't met, the flow just stopped. Dead end. No cost.
Exactly.
Agentforce is probabilistic. It's built around the Atlas reasoning engine. And this engine, it's designed to handle ambiguity, which is fantastic for customer experience.
But a nightmare for budgeting.
Total nightmare for predictable budgeting. It doesn't use Python. It's constantly calculating probability. It's thinking, okay, I have an 80% confidence I should call tool A, but a 20% confidence I should check the knowledge base first. You are paying for that confidence calculation, for every single reasoning step it takes just to decide what to do next.
That probabilistic nature, it's the engine of both its capability and its cost volatility. So let's detail the chain reaction of cost this creates, because this is how the budget variance just explodes.
It always starts with autonomy. The agent is allowed to reason, to plan on the fly to solve some ambiguous problem.
And that autonomy immediately leads to
Loops and retries. If a tool fails or its first plan doesn't work, it doesn't stop. It automatically replans. And every replan consumes more resources, more credits.
And if that replan needs more data to work, now you're into massive context and token expansion. The RAG system starts fetching huge and often irrelevant data blocks to try and ground its next answer.
And all of that cumulative cognitive effort, it translates directly into accelerated flex credit burn. And there it is, the budget variance that gives finance a heart attack on Monday morning.
We have to call this mechanism what it is. It's the reasoning tax.
The reasoning tax, I like that. Probabilistic reasoning incurs a cost per turn or per action. So if an agent is struggling to figure out what a customer even wants, maybe the input was badly phrased or it's a really complex question, it iterates through multiple internal reasoning steps before it even executes the external billable action.
What do those internal steps look like? Can you walk us through a basic example? How does a simple request turn into this complex, billable, internal mess?
Absolutely. So a customer writes in, "My bill is wrong and I want to cancel." That's an ambiguous input, right?
Two things at once.
Exactly. So it forces the engine to start thinking internally. Step one might be topic classification. Is this a billing problem or a cancellation request? Step two, sentiment analysis. How angry is this person? Step three, plan formulation. What data do I need to go get? Step four, refinement. Okay, the data I got. Does it support fixing the bill or processing the cancellation? Each one of those logical turns
Is a billable event.
It consumes an Einstein request or a flex credit before the agent even tries to call an API to fix the bill. Complexity equals cost. A confused agent is a financial liability generator.
So let's quickly frame the basic rates. We need to understand the scale of the traps we're about to get into.
Right. The rates themselves seem manageable. That's the trick. A standard action is what, 20 flex credits? Roughly 10 cents. A full conversation session is around $2. Voice actions, a little more, maybe 30 flex credits.
But the stealth bomber in all of this.
It's the Einstein requests. The internal LLM calls for drafting summaries, for that internal deliberation, for text classification. That's the hidden cost driver. If your agent is poorly prompted or badly scoped, it's just going to cycle through those requests hundreds of times an hour. The cost goes up dramatically, even if it just looks like the agent is sitting there thinking.
Okay, so those are the building blocks, but the real volatility, it's not from the base rate. It's from these two really insidious design choices that hide the consumption until it's way too late. First one, billable event stacking.
This is just fundamental to how the React loop architecture works. The agent's whole strategy is decomposition. It breaks one complex customer request into a sequence of multiple individually bathed steps.
So for the customer, it feels like one interaction.
One interaction. But for your accounting system, it's a receipt printer just running wild.
Let's visualize that. A customer says something like, I need you to summarize my last 10 support cases, check inventory for the replacement part, and then draft a priority email to my account manager with the next steps.
Okay, that's not one action. That is a chain of billable events.
Okay.
Action 1, search knowledge. That's a retrieval action. Action 2, summarize case. That's a generation action, probably using internal Einstein requests. Action 3, check inventory, an external tool call. Action 4, draft email, another generation action.
4 paid events for 1 customer request. And if you're on the standard Flex credit model, these just accumulate linearly, costs just stacking up. We call this a chatty agent, and it dramatically increases the action density, the number of paid steps per conversation.
Right, and it burns credits like crazy with no proportional increase in, perceived productivity.
Yeah.
The agent might close the case a bit faster, but the transaction cost is exponentially higher than the old fixed cost human model.
And if that billable event stacking is bad, the second trap is way more dangerous because it's a hidden cost multiplier. It's driven by configuration. I'm talking about the token context cliff. This is rooted in the documentation's 10,000 token rule.
Okay, we need to clarify for any financial leaders listening what a token even is here, because it sounds technical, but it is a financial unit of measure.
It's a unit of cost.
Absolutely. Think of tokens as the system's working memory. They're like parts of words or chunks of data. When you send a request to the LLM, you send the prompt and all the relevant context. The amount of that context is measured in tokens.
And to make an agent smarter, what do admins do? They use retrieval augmented generation. RAG.
Oh.
They configure the agent to access these massive context windows.
Exactly. They tell it to go retrieve the last 50 emails or integrate a 300-page technical PDF or pull huge data blocks from Data Cloud.
The admin's goal is noble, right? They want accuracy. Give the agent all the information it could possibly need.
But the consequence is financial peril because of that hard 10,000 token limit. Think of the agent's working memory like a bookshelf that can only hold 10,000 tokens for any single action. If you force that agent to read 40,000 tokens of context for one logical step like, say, summarizing a complex case, the documentation is clear. It gets counted as multiple standard actions.
So that one summarize command, which the admin thinks costs 20 credits, can automatically become 60 or 80 flex credits. That's a 3x to 4x cost multiplier just from token overflow.
It is the hidden financial multiplier. The cost is multiplied entirely by your configuration choices, by how much, frankly, irrelevant data you forced the agent to read. You thought you were paying the library fee once. You actually paid it 4 times because the book was too heavy.
And this is how a whole business unit's budget just evaporates. And it's totally invisible if you're only tracking transaction count, not the token weight of the inputs.
Okay, these risks we've just outlined, they're not theoretical. They are the structural failure modes that will define the first financial crises of the agentic enterprise in 2026.
We need to analyze these 3 scenarios. Let's use the lens of trigger, mechanism, and control failure. That's how we understand why they blindside finance.
All right. Scenario A, the recursive apology loop.
And this one is so insidious because it starts with success.
It does. The trigger is deceptively simple. Your Agentforce agent sends a normal, outbound billable message, a paid action. But the external recipient, maybe it's another company's bot or just an email client, replies with an immediate out-of-office auto-response.
And the mechanism? That's where the money burns. The Agentforce agent, it's following its instructions to be polite or acknowledge all input, so it sees that auto-reply as a new, legitimate message.
And so it sends another paid action, a reply, maybe an okay, thank you, or an apology for the delay, which of course triggers the external bot again. And you're off. An infinite feedback loop is established, just continuously burning credits at machine speed.
And the agent is functioning perfectly according to its instructions. It's being polite, but it's financially catastrophic.
Exactly. And this loop is a classic pilot metric trap. So why do pilots hide it?
Because they're sterile environments.
It's surgically controlled, they're small, internal, and you're not deploying them against thousands of SMS numbers or public WhatsApp channels where auto-replies are just a guaranteed part of life. Pilots are engineered for operational success, not for external chaos.
So let's talk about the blast radius. This is where the risk becomes real. You launch a 10,000 message campaign on a Friday afternoon. If only 1%, just 100 users, have auto replies that trigger this loop.
And the loop runs at a conservative 1 paid action per minute, which is slow for a machine.
Over a single weekend, those 100 loops can incinerate, over $14,000 of flex credits. The agent is consuming your budget $247 until a human physically stops it.
The missing control here is obvious. It's the lack of a native automated financial circuit breaker that's based on velocity. The platform's default is a consumption threshold alert, an email.
You cannot rely on a human opening an email at 2 in the morning on a Saturday to stop a machine loop. The human latency gap is the entire vulnerability.
So early detection. The signature has to be a primary focus on your dashboard. Sudden, sharp spikes in burn rate velocity, the rate of credit consumption per hour, that don't correlate with a proportional increase in human traffic. If your volume is flat, but your burn rate goes vertical, something is looping.
And the classic pilot metric trap that hides this is focusing too much on CSAT for that first successful outbound message and totally ignoring the financial inefficiency of the loop that follows. You hit your outbound goal, but you bankrupted the department to do it.
And when the CFO calls on Monday asking where the money went, the scapegoat path is so predictable. You blame the marketing team for the timing of the campaign, or you blame the channel integration.
Anything but the agent's unconstrained probabilistic instruction to be polite.
Right. Okay, second scenario. This one is driven by well-meaning engineers. We call it the data-heavy rag fetch.
The trigger here is overzealous RAG configuration. The admin wants the agent to be authoritative, so they ground it in these massive context windows, huge documents, full transaction histories, big data blocks from Data Cloud.
It sounds like the right thing to do, right? You're trying to reduce hallucination risk by giving it more context. So why is this a financial disaster?
Because the mechanism is the direct, unmonitored violation of that 10,000 token limit we just talked about. The system processes context way over that limit for what should be a single standard action. So it bills that single summary or that single classification as multiple actions, usually 4 or 5, even though the customer only asked for one thing.
So if I tell an agent to summarize a customer's legal history, and that history is 50,000 tokens long, I just paid for 5 summarized actions, even though I only got one outcome. That's that 300% to 400% hidden cost multiplier.
Exactly. The cost isn't in the transaction count. It's in the inflated flex credit burn. It is the silent killer of the budget. So why do pilots hide it?
Simple. They use tiny, curated, clean data sets. They never let the context window get anywhere near that 10K token cliff. They're testing functional performance against a financially unrealistic data volume. The agent is on a clean, control diet.
The blast radius here is pure financial volatility. It creates unpredictable budget variance you can't forecast, and this rapid, unexplained erosion of your flex credits. And it's all due to poor configuration, not genuine growth in your business.
It's like finding out your electricity meter runs faster when you plug in a high-wattage device, regardless of how long you actually use it.
So the missing control is governance over the R-grade configuration itself. You need platform-level governance over the max token size allowed per agent ID. A setting that says Agent 1 is capped at 12,000 tokens per request. If it needs more, it has to stop and ask for a human.
And your early detection is a low reasoning efficiency ratio, or RER. You see this huge credit consumption for one action, that 80 credit summary, but the business value you got is only equal to a 20 credit action. That means your agent is inefficiently processing tons of irrelevant context.
And the pilot metric trap is prioritizing accuracy above all else. The agent gives a wonderfully grounded answer because it had all the data, while you completely ignore the massive billable cost of retrieving the 99% of irrelevant context that created that token overflow multiplier.
And when finance demands to know what happened, the scapegoat path is to blame the data. Oh, it's just unavoidable data processing costs.
Instead of admitting to faulty configuration that violated the documented financial limits and led to all the overspending.
Okay, final scenario. Tool thrashing. This one highlights the critical cost of error recovery.
In a deterministic world, if an execution fails, the system logs an error and it stops.
Right. But in the Agentforce world, the engine enters a costly consumption-driving loop when it fails. The trigger is the failure of an execution tool. The agent tries to do something complex, process a refund, change an order, and the external API it depends on returns an error. It times out. It just fails.
And the mechanism is the Atlas reasoning engine entering what's called the refinement loop. It's programmed to solve the problem, not to quit. So it triggers more reasoning steps, burning more Einstein requests, and tries multiple new billable actions.
So it tries the API again with a different date, then it checks a different refund tool, then it drafts a complex apology to the customer. The agent is just spinning or thrashing without resolving anything, but generating billing events the entire time.
This is a compounding financial loss. You just paid for 3 or 4 actions that failed. In the old world, failure cost you 0 on execution. Here, failure means you accelerate your financial burn as the agent tries to reason its way out of the error.
And why do pilots hide this? They stress test happy paths. They make sure the APIs are clean and healthy and respond perfectly. They do not stress test agents against chained tool failures. They minimize the chances of that costly refinement loop ever kicking in.
The blast radius is severe. It's a double whammy. You have the compounding loss from wasted flex credits on failed attempts, plus the potential for hallucination cost.
Explain that.
That's the aggregated financial value of the concessions, the discounts, the free expedited shipping that the frustrated agent eventually just gives out to close the transaction because it can't solve the core problem.
What's the ultimate control failure here? What's the missing control?
It's simple behavioral monitoring. It's the inability to define a hard fail count limit for an agent before an automated stop or a forced handoff to a human is triggered.
Agents need a stop loss. If it fails to execute a paid action 3 times in a row, it has to kill the process, period.
The early detection here is defined by a toxic overlap of 2 bad metrics. High action density, lots of actions per conversation, alongside a low reasoning efficiency ratio. High effort, low outcome. The agent is working like crazy, but nothing is getting done.
And the pilot metric trap is the focus on reduced handle time. The agent closes the case quickly with a $50 concession, and you completely ignore the 3 failed paid execution attempts that came before it. The cost of the resolution outweighed the problem.
And the inevitable scapegoat path is to point outward. Blame the external API vendor. Blame the customer data quality. Ignore the real failure. The agent's inefficient and very, very billable error recovery strategy.
Okay, we've established it. The human latency gap is the financial vulnerability against machine speed. We need enforceable controls that actually stop the spend, not just send an email that sits in the spam folder.
First, let's do a quick reality check on the digital wallet. Its strength is transparency, right? It gives you granular, action-level usage insights, and it lets you set consumption threshold alerts. It gives you visibility.
But visibility is not control. Let's be very clear. The platform's default is an alert, not a stop. You have to engineer the stop yourself using the platform's tools, because relying on human reaction time against a machine running hundreds of actions a minute, that is a losing financial proposition.
We need 3 mandatory controls that move beyond alerts and get into hard governance. The first one, hard caps and budget isolation.
Finance has to enforce strict flex credit allocation limits, either per business unit or ideally per distinct agent ID.
Why is that per agent ID part so crucial?
Because the goal is isolation. You have to prevent a runaway agent in the sales department, maybe one stuck in a loop, from draining the entire service department's pooled entitlement. If the sales agent runs out of credits, it stops that agent, not the entire enterprise's digital labor force. You need ring-fenced budgets for digital labor just like you do for human departments.
Okay, the second, and I think most critical control, is the burn rate circuit breaker. This requires a custom-engineered solution using native Salesforce tools. This is not an off-the-shelf feature. This is a required governance layer you build.
And this mechanism has to be driven by velocity, not total volume. You use event monitoring or data cloud to calculate actions per hour per agent ID. If a threshold is breached, say, agent X executes more than 100 actions in 10 minutes, that has to trigger an automated hard stop.
Okay, let's explain the mechanics for the governance audience listening. How do you actually implement a hard stop in a live system without killing the entire instance?
You need a system switch that is checked before every single billable action. We recommend using something high performance, like a custom metadata type or platform cache, to store a simple Boolean value. Let's just call it agent kill switch.
So when your monitoring system detects that velocity breach,
It programmatically updates that metadata record to true. That metadata type, it's the gatekeeper.
exactly. The hard stop is then enforced by embedding a mandatory gatekeeper step in every single Agentforce action flow. Before any action runs, it has to check the value of agent kill switch. If it's true, the interaction has to end immediately. It refuses to execute the next billable step.
And that contains the damage to your preset threshold. It has to be non-negotiable and non-bypassable by the agent itself.
All right, the third control is about defining kill switch authority. This is purely a governance decision, not a technical one. You have to define who, by title, has the sign-off to set those circuit breaker thresholds, the 100 actions in 10 minutes limit, and who has the manual override to trigger the kill switch.
And this cannot be a siloed IT decision. It has to be a shared decision right between the CIO, who understands the tech risk, and finance leadership, the CFO, the VP of FP&A, who actually own the P&L variance.
Right. If finance doesn't sign off on the threshold, they can't complain when it gets breached.
Exactly.
Finally, let's wrap this up with the 3 executive metrics that must dominate the 2026 dashboard. These are totally distinct from traditional IT KPIs like uptime.
Okay, first, burn rate velocity. This is your rate of credit consumption per hour.
Good versus danger.
Good. Stable credit consumption that's aligned with your transaction volume. Danger. Sudden, sharp spikes. Those are your leading indicators of an infinite loop or maybe even a prompt injection attack.
Second metric, action density. The average number of paid actions it takes an agent to complete one conversation.
Good. A low average number, which indicates efficient planning. Danger. High or increasing density. That suggests your agent is inefficient, it's chatty, and you need to adjust your budget forecast immediately.
And third, reasoning efficiency ratio, RER. Tying effort to outcome. It's successful outcomes divided by total credits consumed.
Good. A high ratio. Low credit spend yielded a solved case. Danger. A low RER. That tells you the agent is spinning or thrashing, it's burning resources without actually resolving anything. It highlights those costly refinement loops.
Okay, we've detailed all these financial vulnerabilities, but I want to go back to our cold open. Why are you so certain that the first true Agentforce outage will be financial, not technical?
Because the entire architecture shifts the very definition of risk. So let me be absolutely clear. The first major Agentforce outage in a large enterprise will not be a technical crash. The first Agentforce outage will be the CFO pulling the plug.
The system will be technically healthy. It'll have 99.99% uptime.
Perfect uptime.
Okay.
But it will have breached financial policy. It will have bankrupted a business unit through uncapped probabilistic consumption that finance never, ever budgeted for.
And this whole failure mode is masked by the false confidence you get from pilots.
Completely. Pilots are designed to test functional success. They do not stress test the consumption tax. They rely on a narrow scope, clean data, and predefined happy paths where the agent gets it right on the first successful attempt.
But the real world is messy. You've got ambiguity, old data, customer typos, failing tools.
And that environment immediately activates all those costly, inefficient, probabilistic loops we talked about. The recursive apology loops, the tool thrashing, the RAG fetches that blow past the 10K token limit.
The vendor is selling you a powerful machine, but the liability for the financially erratic behavior of that machine, it rests explicitly and entirely with you, the enterprise, not with the vendor.
If you don't build these financial guardrails, you become the enterprise that goes viral for getting a six-figure weekend invoice from your AI system.
So for organizations moving into this agentic world in the coming year, you need immediate, concrete actions. In the next 30 days. You have to mitigate this before you deploy at any real scale.
Action 1. Define your kill switch authority and your thresholds. Get finance and the CIO to sign off on the specific velocity thresholds that mandate an automated stop. Treat a financial threshold breach like a security incident.
Action 2. Implement that circuit breaker. Prioritize engineering the custom financial hard stop using Apex, Flow, custom metadata. Make sure it actively stops the machine from executing the next billable action, not just sends a passive alert.
And Action 3. Establish procurement guardrails. You must integrate non-negotiable hard caps on consumption, audit and export rights for your consumption logs, and guaranteed notification SLAs for budget breaches into all your Agentforce contracts. Do not accept a reporting tool when what you need is a hard stop control.
This has been the deep dive into the fiscal frontier of the agentic enterprise. We'd invite you to subscribe to the CRM Position podcast to stay ahead of the real shifts in Salesforce AI and Agentforce. No hype, just operational reality.
The decision right has shifted, the liability has shifted, the billing model has shifted. Your governance structure has to follow immediately.
If Salesforce AI can burn money while healthy, who stops it in the first 10 minutes?